Welcome to topic 6 of computer programming. And in this topic, we're looking at two subtopics, and those two subtopics are loops and lists. Some of you might be familiar with these topics from earlier classes that we've done, and if that's the case, this should be some helpful revision for you. If you're new to this topic as well, we'll try and introduce it and break it down. So Python is a simple and easy to learn language, and in Python there are only two different kinds of loops that you need to know. You only need to know two, and those two are a for loop and a while loop. So I've added a little flowchart that represents each here. This one, the for loop, is for when we have a given group or a given number of things and we know how many things we have. Okay, so if we have a collection of items, we can say for this collection of items, do this. Okay, and Python will do it, whatever we ask it to, for all of those items, and then it'll stop. Now, a while loop is a little bit different. A while loop has a conditional, and it starts off, and what it will do is it will keep running this condition until the condition is either false or true, depending on how we set it. So it'll keep going until a condition is met. Okay, so while some condition is somewhere, keep doing this. So the difference between the for loop and the while loop is we use for when we know how many we have. We can use a for loop over that. And we use while when we're waiting for a condition or while we're waiting for a condition. Okay, so here's how we'd write a for loop in Python. We just write my string or any variable name as I am a string. And this is just a little example string I've created here. Then we just do for item in string, print item. Now, for means we're about to start a for loop. Item is a variable name. This could be any word. Okay, this doesn't matter. I'm just using item by convention. Okay, in is a keyword. Okay, and my string is the variable that we created up here. So if we think about this, what we're doing is we're saying for a new variable called item, and that item is going to be every single individual character in my string, then print these out, and it prints them out one at a time. I am a string, like that. So that's what Python will do if you say a for loop. And like I say, we know how many characters there are. We've got the characters, so we're going to just loop over that with a for loop. Now, we can add a conditional to that as well. This for loop adds a conditional. We have my string, I am a string, and we can say, just like before, for item in my string, if item is the same as the letter A, print item. And obviously in I am a string, you see we've got these two A's here. Up here, we print out only the two A's. Okay, so this for loop has a little test in it as well. Now, when we write a for loop and we use the colon, okay, this tells Python we're about to say what, for what, okay? For item in my string, do, what do you want me to do for each of these items? When we press the return key or the enter key here, Python automatically indents us by 4 spaces here. And that's how we know that we're about to enter what's called the body of the for loop. So the other type of loops in Python are while loops. And here we have a while loop where we have a number, A is 0, and we're going to say while A is less than 10, so there's our condition, okay? While A is less than 10, A plus equals 1. So that's shorthand for A equals A plus 1, and then just print A, okay? So I'm going to open up my Genie and just show you how that looks, okay? So let's do a new Python script and we'll call this examples.py. So while, let's first of all set a to be 0, okay? While a is less than 10, and I'm just going to press F5 to save this, examples.py. Okay, while a is less than 10, when we press return here, Python automatically indents us, okay, print a, right? So I'm going to press F5 here to run this. Okay, and what that's going to do is that's going to print out the number 0 forever, because a is 0 and it is less than 10. So that condition is never going to be met, because a is always going to be less than 10. It's never going to change. It's an infinite loop. So let's cancel that, keyboard interrupt, and let's add some more activity to the loop. So let's do a equals a plus 1. Now, shorthand for that, okay, a quicker way to write that is just a plus equals 1. It's exactly the same as a equals a plus 1. So now, what we're saying is, while a is less than 10, take a, add 1 to a, and print a out, okay? And we can even add something a little bit more elaborate in here. Let's put in the value is now, okay? Right, press F5 to run it. So look, here we go. The value is now 1, the value is now 2, the value is now 3, and so on all the way till 10. All we've done here is we've added 1 until this condition becomes true. A is no longer less than 10. Then it'll stop. Okay. So there's a really, really simple example of a while loop there. Okay, now we can add conditionals and things just like in our other loop, like we did with the for loop. So here we have a variable called count, and sometimes this could be called an accumulator variable, okay, because it accumulates numbers as the loop runs. So we start off up here with count being 0, and then we're just doing count plus equals 1, print count, okay, and in this case I'm saying it's less than 5. Now, what I've done here as well is I've added an else condition to the while loop. So rather than just finishing off when the condition is true, we have an else as well, just like we can have in an if statement. Okay, so those are our loops in Python. We only need to know 2. There are only 2 to worry about. That's what makes Python really simple. So the next topic to look at is lists, all right? Lists, a list variable in Python is a slightly more abstract data structure than just a simple string. So in Python, a list is a collection which is ordered and changeable. In Python, lists are written with square brackets. So here I have created an imaginative list with 3 animals in it: dog, cat, and horse. Okay. I probably wouldn't win a prize for imagination on this. And we can print this in exactly the same way as we print any other variable. Okay, and if we do that, it'll print out the whole list. All right. So we can also access items in the list just like accessing strings using the index number. So we can print out, for example, the first value in the list using the square brackets and 1. Actually, that won't print out the first value, being very silly. It'll print out the index 1 value, which, as we know, is actually the second item because indexing starts at 0. So a really quick example of a list. Let's say here's, okay, my list. We press equals to assign my list, then we do square brackets. And in my list, we'll put apples, oranges, and let's say pears. Okay, so there's a list with 3 items in it, okay? We've got apples, oranges, and pears. Now, with those three items, we can just print, okay, my list. So let's press F5 to print that. Okay, printing out apples, oranges, pears there at the end of our while count to 1 to 10. You know what we'll do? We'll just turn off the print in that while loop there, so we can just see the list. So here, let's print that list there. Apples, oranges, pears. Now, let's say I only want to print out the first item in the list. We just do that, okay? Give it the index number of the item we want to print, okay? All right, so we can also have, just like with strings, we can also have negative indexing, okay? And negative indexing begins from the end of the list, and we can count back from -1, just like we did with strings in the last topic, okay? So my list -1 would give us this last item here in the list, okay? We can also do a range as well, just like we can do with strings. And just remember, if you do :4, that implies that this has a 0 here. Okay, so that is a list range. That is the list index values. Here's some more examples on some lists. So we can go from position 2, and leaving this blank would mean to the end. We can run a list from the -4th position to the -1 position. Okay, so we can access the list items based on indexes. All right, so let's say we want to change a value in a list. It's as simple as just calling that value. So a quick example of doing a wee change of a value. Here's my list here. Okay, so running this again, it's going to print out the first item in the list. Now let's say we want to change a value in the list. All right, we want to change something. Let's go, okay, my list 1. And then what we're going to do is open up these square brackets. All right, and inside the square brackets, we're going to specify what we want to change. So I'm going to change oranges. Okay, so we know oranges is at the 1th, the first position, okay? So let's do, or my list 1 equals, and let's put in brackets what we want it to equal, in quotes. Let's change it to onions, right? Onions, right. So let's run this, and then let's comment that out. Oh, no, let's leave this print in. Print out the whole list, and then we'll print it again under here, because remember, Python interprets one line at a time. So let's run it. So you can see, hopefully, let's just clear and we'll run that again, that initially the list had apples, oranges in pairs, but after changing the value at position 1 to onions, the list now has apples, onions in pairs. Okay, now there are a couple of other ways to get into a list and change things. We can go in and we can use a couple of specific functions. Here's an example of looping over a list. So just like we were able to loop over a string, over the characters in a string, we can do it in exactly the same way as a list. Just for x in my list, print x. So here's a function to check for a value. Let's do if horse in my list, print yes, horse is in my list. And obviously I've created a list, and inside it there is horse. So we can use this conditional to test for a value. We can also print the length with the length function there, and pass in the list into the length function, and then pass that into the print function. Okay, so couple of other ways. I said there were a couple of other ways to add items to a list, and there's mylist.append. So what mylist.append will do is add an item to the end of the list. Okay. And there's also mylist.insert. mylist.insert will insert something into the position, and you specify the position number there. So the last part on lists would be removing items. And we can remove items with mylist.remove, and we can also delete a list using del for delete mylist, and we can also use a function called mylist.clear to clear the contents of a list. So those are an introduction to some loops, an introduction to some lists. Let's just move forward and look at what happens when we put the two of these together. What happens when we loop over a list? So I've come up with an example here. This is an example of a list of numbers, and I'm going to say for item in numbers, if the modulus of the item, if the item modulus 2 is equal to 0. So this is a way of checking if a number's even or not, okay? Because when modulus means what's the remainder after the division. So if the item modulus 2 is the same as 0, print the list contains an even number. And I've actually been quite sneaky there, and I've written a whole list that doesn't contain an even number. So this would be a pointless exercise, shall we say. So I think also this print should be indented. I think that's a little bit of a typo there, but I think I was struggling to fit it onto the page. So there we go. So numbers is equal to a list of numbers, and then for item in numbers, if item modulus 2 is the same as 0, print the list contains an even number. Now, I'm also using another kind of built-in keyword to Python, break. Okay, and break is just a way of breaking out of a list. So to break in a for loop, we actually use a thing called a breakpoint. It's a unique function in a for loop that allows you to terminate the execution of the for loop. So in this example, we declared a range of numbers between 10 and 20, and if the number is the same as 15, break. So what will happen is we'll print out 10, 11, 12, 13, 14, but then when x becomes 15, break out of the list. All right, so those are the contents of topic 6. We've looked at the different types of loops in Python. We have two loops, for loops and while loops. And we've also looked at the different types of lists and the operations we can do on the list variable. Okay, the things we can do. We can get into the list, we can remove stuff from the list, we can add stuff to the list, we can look at the index of the list, we can check the list, and finally, we can put the two things together and we can actually loop over a list and print out the items. Welcome to topic 7. So in this topic, there are 3 subtopics, and those are dictionaries, functions, and modules. So let's have a look at the first one, which is dictionaries. So we already looked at the list type in Python. The dictionary is has slightly more layers to it. So first of all, before we look at the dictionary specifically, let's talk about key value pairs. So in computing, fundamental data representation, a common data representation is called a key value pair. Okay, now it's sometimes called an attribute value pair, sometimes called a name value pair, or a field value pair. And the idea is that you have some key here, in this case name, and some value associated with that key, and the two of them are a pair. Okay, so this type of data representation is very common in computing. And if someone says, you know, we have attribute value pairs or name value pairs. This is what they mean. They mean you have some keys and some values and they're related. And this is a common way to store data. So let's move forward and look at a dictionary. So dictionaries are sometimes called hash maps in other languages, key value stores, and really a dictionary is just a series of key value pairs. So I've created a dictionary here, and slightly different from a list, when we make a dictionary, we use the curly brackets, curled braces, okay? And we assign with equals as before, and we set a name. But this time we separate using this colon character. That's the delimiter of the items in a dictionary. So I've created a dictionary here called test results. This test was out of 100. Okay, so I have, let's say, 3 people took the test: Hopeless Helga, Big Jimmy, and Clueless Charlie. And of course, Big Jimmy got 84 out of 100, whereas Clueless Charlie only got 22. So that's why they call him Big Jimmy, because he always gets a very good score on these. So what the value in this is that we can go into a dictionary and we can pull out keys or we can pull out values, and we'll look at how to do that in just a second. So what we have here is a dictionary I've created called My Dictionary, and in My Dictionary we have some keys and some values. So here we have a dictionary I created. This is about a pair of trainers, another prize for imagination here after my very exciting list with a horse, dog and cat in it. So here we have a dictionary about trainers, and I've created the key, colour, and I've assigned a value, black, brand New Balance, model 373. Print My Dictionary will print this out. Okay, so we can actually do some operations on the dictionary. Once we understand that we have a set of keys and values, we can do some operations on there. So let's have a look at some dictionary operations. So I'm going to make a dictionary. Let me just get my editor open and we'll make a dictionary just to show some examples on it. So what I'm going to do is I'm going to clear this stuff out. Actually, we'll keep that for later. So let's create a dictionary, a simple dictionary, okay? So let's do My Dictionary. And then we're going to assign a value to the dictionary by doing equals, okay? Now, just like with a list, we need to then open our brackets to say we're about to make the dictionary, but this time we're going to use curled brackets. And then we're going to put some key into the dictionary. So the first key we'll say will be like make. Now let's put this into, it's trying to be too helpful, isn't it? Okay, make. And then what we're going to do is separate make with a colon. Okay, so we're going to do make, let's say Ford, and then separate this key value pair to the next key value pair with a comma. Okay, so make Ford, and I've just pressed return there just to get us onto a new line. We could do this all in one line, it just makes it more difficult to see. So model, and let's do, I forgot to put that into brackets, let's do model, okay, and then colon space Fiesta, okay, and then we'll do, forgot to put a comma there, color, or we could spell color the American way, live on the edge, color, colon, okay, and we'll say red. All right, so there's 3 key value pairs. Let me just move that back there to make this a bit easier to read. So we've got a dictionary, and in the dictionary, we've created 3 key value pairs: make, model, and color. Okay, And for the sake of getting it all onto one screen, we've spelt colour the American way, dropping the U there. Okay, so now if I press F5, I'll just save this first of all as dictionary examples .py. All right, so we've got some syntax highlighting there. Now, what I'm going to do, first of all, just to show you what happens if we just print the dictionary as it is. So let's do down here, print, okay, my underscore dictionary. Right, run. So look, what that's doing is that's going to print out the whole dictionary. Make, Ford, model, Fiesta, colour, red. Now, sometimes you might only want to print the keys or only want to print the values, okay? Or we might want to print them out one at a time. Just like I showed you before, we can run a for loop, okay? For item in my dictionary, colon, print. Hell if I could spell print. Let's print item. Let's see what happens when we run this, okay? Okay, so what that's doing, let's just comment that one out so that we, okay, so I'll put a little comment after this and I'll say prints whole dictionary. For item in my dictionary, print item. Let's run this one. So what that prints is only the keys. Okay, so I'll put a comment after here, print keys. So then how do we get into the dictionary and just print the values? Well, let's head back over to PowerPoint here and we'll have a look. So to get the keys, we do for item in my dictionary, print item. That'll print us out the keys. To print the values, okay, we need to specify the variable in square brackets here. I'll just give you a little example of that now. Okay, so pretty much the same for loop, just a slight change on it. So let's go from here. For item in my dictionary, print item. For item in my dictionary, this time we want to print my dictionary and then put item into square brackets. All right, let me just run this just to check I'm right here, doing this from memory. Okay, good. Let's comment that one out there and let's say print values. So to print values, we just need to run this, all right, and it'll print us only the values. Let me just clear that there to show you again. Print values. Oh, something it doesn't like. What doesn't it like? Okay, so unexpected indent block. See, it doesn't like that because I've got a print without something happening. Let's see if this works now. Okay, it's happy now. It wasn't happy before, it's happy now. So there's print keys, there's print values. The last thing I can hear you asking is how do we print the keys and the values? So let's have a look at printing keys and values. To print keys and values, we have to specify two temporary variables, key, value. And then we have to say in my dictionary dot items. So let me just show you one more example. We'll take a copy of this and edit the code here to do this. So let's do for item, okay, change that to for key value in my dictionary dot items. Okay, print, and it's actually a lot easier than a lot less complex than this. Print key, comma, value. All right. So we'll change this to print key and value. Let's run this one. There we go. See, it's printing key and value there. So print the keys with this, print the values with this, print key and value there. And we can add if statements and tests and things to this as well. So that's just a quick overview of dictionaries. There's more detail on this in the learner's notes to look at. But let's have a look at our last topic today, and this one is functions. So when we want to create a function in Python, we're going to use a keyword, and that keyword is def, and def is short for define. Okay, so a function is a block of code that only runs when it's called. You can pass data to a function, and that data is known as parameters. Okay, actually known as arguments, really. Arguments, parameters. A function can return data as a result. A function is defined using the def keyword, and here's an example of a function. So I've defined my function. Now, we can print. So this function, my function, its only job is to print out hello from a function. And then all we need to do is call the function in our code, and to call it, we just say my function and put these two brackets here, and that will call the function. Now, these two inside this function, my function, x and y, those are called the formal parameters of a function. So this function, my function, has two formal parameters, x and y. Okay. And there is a keyword we can use inside a function, return. So when we call this function, it's going to return the value of x plus y. Now, when we send values in to a function, those are known as arguments. Okay, so we send, what we're doing here, okay, we're running the print function just to print out the output. So this is the print function here. We're then going to print my function, which is this thing up here. Then what we want to do is we want to substitute into my function two arguments. So this 3 here is going to be substituted into here, into the position of x, inside the body of this function, and the same with 4 into the y position. Then the function will take the value of x and y, and it will return x plus y when we call the function. So we already looked at, I think this was maybe in topic 3 or topic 4, a simple program that will convert between systems. Now, this program converts temperature, and there's a formula for converting Fahrenheit to Celsius, and that is Fahrenheit is equal to 9 divided by 5 times Celsius plus 32. So we don't need to memorize that or anything. Let's just accept that that's how you work it out. So at the moment, we have a variable called Celsius, and we're assigning to that variable some input, enter a temperature in Celsius. And then we have the calculation, and we're going to print out temperature is Fahrenheit. So we're going to pass this Celsius variable into this calculation here, and then assign the value of this calculation to this variable, Fahrenheit. Then we're going to print out this variable. Now, this works, but we could write this as a function. Okay, so here is a temperature function that I've created. So it's called myTemp function, and it's got one formal parameter. Okay, so we could send in an argument, 1, which will be known as x. And then x is substituted into this calculation here. And the function will return whatever the result of this calculation is. And then to call the function, we just call myTemp function, okay, and we send in a value. And we're going to send in a value that we get from Celsius. Okay, so once you've had a little bit of practice of making these, they're actually quite straightforward. And we've already been using functions up to now, we just maybe didn't call them functions specifically. We've already been using print, okay? And when we open these brackets, we're actually sending in values to the print function, okay? We've already used len. Len should be here somewhere. Len, there's len there. Len, the len function gives us the length. So these are some built-in functions that are already there for us in Python. It would be quite silly for us to try and define a print function or a type function when such a function already exists. So the little last kind of related topic to this is about modules. So these are built in already, and we can think of these as tools that are built in to Python by default. But let's say we're doing something a little bit more specialist, okay? So if we're doing something specialist, we might want to import a module. So let's say, for example, you were doing a lot of work on chemistry or biology. You might have a lot of specialist kind of calculations and terminology that no one else will really use outside of that field. So sometimes in programming, you can get a library of specifically kind of built tools to use, and we can import that and then make use of it. There would be very little point of shipping the default version of Python with a load of really specific tools for specific industries. So we can add stuff on. And the way to do that is just to do import, and then we specify a module name. Okay, and we can create an alias of it. We can say from this module, import some individual part of it and give it this nickname. So here's an example of time. This is a module we can import. Now just imagine if you had to sit down and write out all of the different things to do with time. What's a second? What's a minute? How many seconds are in an hour? How many minutes are in a day? What if it's a leap year? How many years are there? What year is it? What day was it on? What year? What about daylight savings time? So that would be rather tedious and annoying. So luckily we can just import a module called time. And then if we call time, it will return this. Okay. If we call ctime, it will return something a bit easier to read. So we just import time, and then from time import ctime, and then with ctime we just send this value here, and it will return us the actual date and time in a kind of human readable form. So here's another module we could import, calendar. Really easy, just type import calendar. And then you say cal equals calendar.month. You specify a year and a month, and then you can print it out. One that's more specific to cybersecurity is this module called HashLib. And this is just a library of stuff to do with hashing. You can generate SHA sums, you can generate MD5 hashes with this. And this is quite kind of common library to use if you're doing hashing in Python. So this MD5.hex digest is a common thing to see if you're looking at kind of cybersecurity and, you know, IP address related stuff. You'll often see this library called HashLib. And the way to think of a library is just imagine a big like old-fashioned library, and by default Python's got some tools to get it going. Okay, it's got the basic stuff you need, but let's say you want to add some functionality on. Just imagine walking down the library and picking up this big book about HashLib or about calendars and just adding that in to your existing kind of collection of knowledge. So that's the end of topic 7. I'll stop now and see if anyone wants to ask any questions. And then we'll have a look at what's in the labs for today. here is lab 6. And in lab 6, what we're going to do is we're going to do some revision on some operators just to see what happens when we run these things. Then what we're going to do is we're going to test out a while loop and a for loop, as we talked about today. And then what we're going to do is we're going to create a program, and this program will run a for loop over a string, and it will read out the values in the string like a team of cheerleaders. So it will say, give me an A, give me an S, give me a C, give me an O, give me a T. I'm sure you get the idea. Okay, so now interestingly, I've added a little kind of else condition to this. I may not have got this 100% right, but when we say a vowel, okay, like for example, give me, and then we have the letter O, right? O starts with a vowel, so instead of saying, we wouldn't say give me a O. Okay, that would be, give me a O, it doesn't sound right. So it's give me an O. So what I've done is I've created these letters here. Now, these letters are letters that you say a before, and all the other letters you say an before. So yeah, so that should be interesting, all right? Now, I might not have got this exactly right. I went through the alphabet and I tried to think about, so give me an A, give me a B. So look, B's there, although it should probably be before C. Give me a C, give me a D, but then you say give me an E. So E is not in here. So we're going to create this program and watch it running. And it's an example of doing an else condition in a for loop. Okay, then we're going to create another one called a vowel counter. Okay, so what this does is this is going to count the number of vowels in a letter, in a word, in a string. So for example, if we said cat, the vowel counter would return 1 because there is one A in cat. Then we're going to modify this program to make it a little bit more interesting. Then we're going to do a short exercise on a list. And then we're going to do something interesting. So this should be a little bit more of a challenge. Now what I have here is a French roulette wheel. Now, the difference between a French roulette wheel and an American roulette wheel is that a French roulette wheel has 1 0 and an American roulette wheel has 2 zeros. So in America, you can land on 0, but you can land on 00 as well. So a normal roulette wheel that's French only has 1 0. So if you see a roulette wheel and it just has the green 0 here, that means it's a French roulette wheel. Now, there are some areas on the roulette wheel, okay, and those areas are written out here. So this part of the roulette wheel, all right, these numbers here are called jeu 0, okay, and that means 0 game, okay. This area of the wheel is called voisin de 0, and that means that these are this bit in here, okay, this area, are called the neighbors of 0 or 0 neighbors. Okay, these two wee bits here are called orphans, and this last bit here is called a third of the wheel, tiers du cylindre. Excuse my terrible French. So, right. So what I've done is I've created a program here, and this program will give you a random number. Okay, I'm going to import random, and I'm going to create a variable called spin value, And random.randint is going to print out a number between 0 and 36, representing one of these numbers on this roulette wheel. Okay, so it will print out a number. Let's say it prints out 10. Okay, its spin value will have the value of 10. Now, what you need to do is write some code under here to say where that value is. So for example, if the value came out on 22, you would say the wheel landed on 22. This is in the voisin de zero area, or the zero neighbors area. Okay, if it landed on 1, you would say it's in the orphans area. You can use the English, or if you feel particularly exciting, you can use the French term if you like. I don't mind. They're quite similar words anyway. So that is lab 6, all right, the roulette wheel. And then lab 7, so this is the last lab where we have to edit a Word document, okay? This is the last of this type of lab. So edit this document, upload it to the Moodle with your solution, and then we move on to lab 7. So lab 7, there's no more Word documents after this. This is just Python from now on. Lab 7 is based on a turn-based RPG. So if you aren't familiar with a turn-based RPG, we'll talk about that in a second. Okay, what a turn-based RPG is. So I have written out some code here, and I'll just copy this over. Let me just copy the whole thing over into my editor, and it'll be easier for me to go through. So let's just do a new, and let's just save this as rpg.py. Okay, so this is available for you to download, this code here. Now, I've created 2 dictionaries. Okay, you should be able to tell by these curly brackets. Well, let's start from the top. I'm going to import random again. Very useful function, gives us random numbers. And I'm going to create a function called attack. And that function is going to return a value between 1 and 20. And that is it. Okay, that's all that bit does. Then I'm going to create 2 dictionaries with 2 characters. Okay, one of them is called cloud, and one of them is called enemy. And inside these dictionaries, there are some key value pairs. Okay, name, which is obviously their name, health, and magic. Okay, and health and magic are both integers. Okay, health for cloud is 100. The enemy has 110 health. Cloud has 50 magic, and the enemy has 40 magic. So then what we're going to do is we're going to create another variable called attack cloud, and we're going to run the attack function, which is here, which will give us a random number between 1 and 20. And we're going to do the same for the enemy. Okay, so attack cloud and attack enemy are both going to get a number associated with them between 1 and 20. Then we're going to print those out to see what they are. Then we're going to access the cloud dictionary and print out cloud's health using print cloud health. Then we're going to create a variable called new health, and we're going to make new health be equal to cloud's health minus the enemy's attack. So let's say the enemy's attack was worth 10, cloud's health is 100, cloud's health points will go down to 90. Okay, then we just print out. Then we're going to update health in the dictionary with new health, and we're going to print out cloud's status now. We'll print out all of his attributes. So that's the code I've already written for you. Okay, that's all there. That's all working. What I want you to do is take this and adapt it to answer the following questions. So question 1, in here, I want you to create a print statement that prints out the enemy attack variable. And I'll give you a clue. Print and then the name of the variable. So that should, number one is an easy one, okay, it's a giveaway. Number two, create a variable called enemy health. So surprise, surprise, we would just do to create the variable, okay? Print the value of this. So that would just be print, okay? But we're going to need to put the actual enemy's health in here, okay? And I'll give you a clue on how to do that. There's Cloud's health up there. Okay. Number three, create two new variables called attack2 enemy and attack Cloud2, and use the attack function to generate a random value for each of them. So two variables here and a random value for each. Then, as with the first attack, so the attack that's shown up here, okay, subtract the values of attack 2 from the health of Cloud and the health of the enemy. And then, number 5, we're going to create a function called fire. Okay, so I'll give you a clue on that one, def fire. Okay. Now, this function fire, okay, is going to do, when it's used, when the function's called by Cloud, it's going to do 10% of the enemy's health damage, but it's going to cost Cloud 5 magic points to use. Okay, so we need to create that function here. And then finally, number 6, write the code of Cloud using fire on the enemy twice. So just remember, fire has to do 10% damage to the enemy's health. So if the enemy has 100 health, fire will do 10 damage, and it will cost 5 magic points. So Cloud's magic would go down to 45 if he used fire. Okay, so you'll need to update the character dictionary, the attributes in the dictionary, and update the enemy, obviously, if the enemy is being attacked with the fire function. So that is topic 6 and 7. Those are lists and dictionaries, loops, functions, modules. There is a lab with a roulette problem and some practice on some of the concepts that we had, and then moving into a slightly more detailed script that you have to write, adapting something that I've started off for you. And that is the end of this week's information.